Good morning. You are welcome to our course Manufacturing Processes 2. Now we are going into module 8, jigs and fixtures for machine shops, and the lecture today is the purposes of using jigs and fixtures in machine shops and the principle of design of the jigs and fixtures. Now what are the contents today's lectures? To enable the students at the end of this lecture define fixture and jig. So, definition of fixtures and jig that are used in machine shops, conceive the purposes of use of jigs and fixtures, why do we use it, then the design considerations for jigs and fixtures, and finally illustrate the methods of locating, supporting and clamping are the major activities of fixtures and jigs, of jobs in jigs and fixtures, and then guidance of tools by bushes in jigs. So, these are the content today, and next day we shall complete it by giving specific examples of design. Now, the definition. Before I go into definition, let us see that suppose there is a block. There is a block, at one point a hole has to be made at a distance from this side and at a distance from this side, through hole has to be made. Now, this can be done without jig fixture and with jig fixture. What is there in fixturing or using fixture? Here you can see this block is shown over here. This is the block which is supported on strong pins and located in Z direction. Then it is located, the axis of the hole to be machined from this distance. So, this is located by this pin, and there are two more pins on the back side to locate with respect to y axis. Now, the job has to be clamped. So, this is clamping to hold the job tightly in position and orientation, and then the drilling has to be done, but the drill is a very slender tool. It can undergo run out and then inaccuracy, oversizing of hole, then working in poor surface finish. So, the tools of such kind need a guidance which will keep the tool steady and position with respect to the job desired. Now, to fulfill this condition, these requirements, jigs and fixtures are used. Now, then what will be the definition of fixture? It is a mechanical device, very strong and rigid, designed and used in machine shops to enable easy, quick and consistently accurate, that is every time it should be same, easily, quickly and accurately, locating here, supporting here and clamping the blank against the tool for higher productivity, because this will save lot of time, and product quality for repeatability and control in batch production. Then what is jig? Jig is also nothing but a fixture. Jig is also a fixture. Only difference is the jig contains one additional feature, that is guidance of the cutting tool. So, when a fixture possesses a guidance to the cutting tool, it becomes a jig. Now, before we go into design and jigs and fixtures, or select or decide we should go for jigs and fixtures, let us have a look into the steps usually followed in machining without fixture Still in many industries for 1 or 2 pieces jobs are done without using any jigs and fixture, and this is done in very conventional ordinary machines. Now, suppose there is a disc, this is the disc, okay, is a pre-machine turned and facing, all this have been done. Now, a hole has to be drilled. This hole has to be drilled at a radial distance, say x, which has to be maintained, and it is a through hole. It is a through hole of diameter, say small d, and this diameter is capital D. So, this is the task. Now, what will be the steps to be followed? First of all, what has to be done? First of all, what we have to mark, this surface, one surface face of the job has to be marked by chalk or something, whitened, and then this line has to be one radial line has to be drawn, and at right angle another line has to be drawn, scratching by scratcher, so that this distance is x as desired. Then at this point a punch, a center punch has to be made, a mark, permanent mark, which will be the piloting the drill, and then by a compass you draw the periphery of this circle to be drawn. Now, to make it permanent, this periphery has to be marked by prick punch. So, it is said that marking and punching of this hole. Now, mount and fix the blank on the machine bed. So, this blank has to be placed on the machine bed directly and then clamped, or this can be mounted on a vise with proper alignment, support and clamp. Now, this job, suppose this is the drill position. So, this job has to, the axis of the hole to be made should be aligned with the axis of the drill, then only it will be all right. So, the axis of the hole to be made and axis of the drill, that have to be aligned. So, for that what has to be done? Adjust the tool work position by shifting the job and then you clamp on the bed, or this job mounted on the vise will be shifted along with the job to bring the axis aligned, or the tool has to be moved. Suppose it is a radial drilling machine. In radial drilling machine, the job is first fixed on the vise or directly on the table, and then you bring the tool by tilting this radial arm into position. Then initiate machining, but immediately after starting machining you check the correctness of the axis or position. Then you correct it again, adjust it again if required, though it is tedious, but it has to be done. Once you are satisfied, then complete the machining work, and after doing work inspect and measure everything again to check whether the job has been done perfectly or not. Now, friend, you have seen that doing this work, simple work, it is so tedious, so many elementary works are involved, each is manually done, and it takes a lot of time and effort and skill of the operator, which makes it very expensive and time consuming. Now, what is the solution to that? Solution to that will be the basic purposes of using jigs and fixtures. Now, first of all, to eliminate those tedious activities like marking, punching, mounting, trial based positioning of the vise or job, and repeated checking, measurement, this tedious time consuming work have to be eliminated, and that can be done by use of jigs and fixtures. Easy, quick and consistently accurate, repeatedly accurate locating, supporting, mounting and clamping of the blank against the cutting tool, so that it does not move at all. So, this will be done easily, quickly and consistently, it will be so designed. In addition to that, guidance of the cutting tool like drill, reamer, some say boring tool also, special type, or say countersinking tool, which are slender in nature because of the cantilever action, then they have to be guided by bush to raise productivity, because the work will be much faster, and maintain quality consistently. So, the quality will be repeatedly maintained, there will be no variation piece to piece. To reduce operators labor and because the labor has to do little work and easy work and skill requirement. The operator need not be very skilled worker, he can be very ordinary type because he will be assisted by, aided by the fixture to attain close tolerance, that is accuracy and interchangeability. So, the repeatability will be maintained, whatever tolerance is decided or apprehended, that will be repeatedly obtained in each of the jobs. So, those jobs which will be produced by that particular jig or fixture will be interchangeable to each other. Finally, to reduce rejection and overall cost. Now, the economic application of jigs and fixtures. We have to see the economical aspect. Shall we use jig and fixture? If you use it, will it be economically viable or justified? That has to be checked. Now, how? The modes of machining. Suppose a lot of job have to be produced by machining. What are the possible modes? One, in ordinary machine like a lathe or drilling machine or planing machine or milling machine without using any jig or fixture. Now, let us come to this plot, okay, graphical representation, which shows machining cost, total machining cost CT versus volume of production or number of pieces Q. Now, when we consider in ordinary machines without fixtures, that is W, this one, this is the graph, this is the initial cost and this is the labor cost, etc., for which the cost is gradually increasing. Next is in ordinary machines, but using jigs and fixtures. So, some additional cost will be required to incur the jigs and fixture, say another few thousand rupees, and but the labor cost will come down because it will be much faster and easier. This is F, okay, using jigs and fixtures. Third one, in automatic machines without or with special fixturing. Now, these special automatic machines are special purpose machines where locating, supporting, clamping are inherently automatically done very quickly, but these machines are very expensive. If we do use this automatic special purpose machine, work will be done very fast and this labor rate will be very low, but the initial cost will be quite large. The initial cost will be quite large. So, this is the three conditions. So, what do we understand from this? You see that so long the production size Q is less than this value, okay, less than this value, then which one is the most economic? The most economic one is mode number 1, that is without jig fixture. When the production size volume Q is greater than this value, that is a mass production, then the automatic system or special purpose machine is most automatic. So, for the mass production region M, the automatic system is special purpose machine is economically justified. For very few pieces, that is called piece production or job order production, the conventional method ordinary machine without jig fixture is most economic. But what about this region in between, that is B for batch production, a small lot? We find that in this case the bottommost line is the W, is a F, sorry F, that means use of fixtures. Let me clean it. Now, you can see for this batch production region, for the batch production region, the bottommost line is belonging to F, that is jig fixture. So, we can machine. Therefore, it is clear that mode 1 is suitable, economically viable for piece production or job order production. Then automatic system is suitable for mass production because it is expensive, and for batch production use of jig fixture is most appropriate. Now, the design of jigs and fixtures. What shall we design? Which part we shall design? Let us see what are the major parts comprising the jig or fixture. Now, here again you recall that this is the workpiece. Suppose this is the workpiece where a hole has to be made, okay, at a certain distance from here and here. Okay. So, this is the blank this is the blank on this side, the side view, which is mounted on 3 supports and then located by this pin and these pins and clamped here, then located, then the tool, the drill is guided by the bush. So, what are the basic elements involved and need to be designed? First, the base of the, this is the total fixture, the base has to be designed, which has to be strong and rigid, and the body. Next is locating systems or elements, that is this locating, this one and this one, these also work as a locating in respect of jet direction. Then supporting system, these are the supporting systems which have to be properly designed. Then clamping system, this is the clamping system which have to be designed. And then tool guides, this is the tool guide with the bush and the frame flap have to be done. Now, indexing system. Now, what is indexing system? Suppose we want to do, say there is a disc, all right, and we want to make a number of radial holes. So, 1, 2, 3, 4, 5, 6. So, after making one hole, this has to be indexed. Then you make a hole here, then you make a hole here, this is called indexing. So, indexing system has to be provided if needed, and auxiliary elements like nut, bolt, fasteners, etc. So, these are the elements which are involved and need to be designed and especially considered while designing. Now, friend, before you go into design, please remember there are certain factors to be considered before designing. Factors essentially considered during design of fixtures and jigs. What are those factors? Easy, quick and consistently accurate locating. First of all, locating is a must. What is locating? Positioning and orienting the job against the cutting tool properly, so that the job machining work will be done exactly at the right attitude and location. But this has to be very easily, quickly and accurately done and repeatedly. Then provide strong, rigid and stable supporting. The supporting pins or surfaces should be strong to resist the stresses, to counter the stresses. It should be rigid to prevent or reduce bending or deflection, and it should be stable to prevent toppling or ship movement. Quick, strong and rigid clamping. So, clamping, holding the job tightly against the cutting force and other forces. It should be quick, it should be strong enough, and it should also be rigid to reduce the deformation. Tool guidance for accuracy and safety. Accuracy means the positioning will be accurate because of preventing of the run out, and safety, the tool will not break because of the guidance. Easy, quick and uninterrupted loading and unloading. Yes, the jig fixture should be so designed that the job blank can be loaded into the fixture before machining and after machining can be removed easily, uninterrupted by other systems. Use of minimum and standard parts. Yes, while designing we should consider that it should possess minimum number of parts. More parts means a larger family where there will be more chances of failure and more requirements of maintenance. So, this will increase the cost and reduce that increase the downtime. And also the parts should be of standard parts, that which are available already in the market as far as possible. As a result, the cost will come down and replacement cost as and when required will also be easy and less costly. Adjustable locating for part size variation. Yes, when we go for locating this one, if the part size slightly varies and the distance of this hole from this range slightly tends to vary, then the screw will be adjusted to change this position X. This is called adjustable locating for part size variation. Chip removal, yes, it should be taken care of. The chip should not be allowed to jam at certain critical points and hamper the operation of the jig fixture. It should be so designed that chips will be automatically disposed and should be cleaned easily. Simple but accurate indexing if required. Ergonomics, yes, comfort, convenience of the operators and safety of the operator, of the tool, of the machine, everything. Manufacturability, design such that which can be really manufactured easily, quickly and economically. Don't design anything which is very difficult to manufacture. Then service life should be long, durable and the cost should be reasonable. Now, design of fixtures and jigs. Major functions of requiring the major functions involved in fixturing requiring proper design. What are those? Locating of the blank into the fixture, supporting the blank by supporting system, clamping, or this is the clamping of the blank inside, and tool guidance. This is the tool guidance, okay, tool guidance. This has to be considered. And what is the other one? Tool, yes, tool guidance is this one. So, these are the 4 activities should be considered. Tool guidance for jig only when there is a question of drilling. Now, friend, there may be several methods of locating, supporting, clamping, tool guidance depending upon the job, its size, its shape, the material, the machining requirements, say turning, the milling, shaping, planing, surfacing, drilling, boring, reaming, and cutting tools. What kind of cutting tool you are using, what is the size of the cutting tool, and what is the shape or geometry of the cutting tool. So, there are so many ways of clamping, locating, supporting, but whatever you do, certain rules and principles have to be followed while designing for clamping, supporting, and locating. Now, come to locating first. Fundamental requirements for locating, supporting, and clamping, all these 3. Now, suppose this is the workpiece of blank. Okay. This is a job which has to be machined, say drilling or surfacing something, but it should be when fixed, that is by locating, supporting, and clamping, it should remain in a particular position and orientation with respect to the tool, all right. And secondly, after locating, supporting, clamping, or during machining, it should not move at all, totally arrested. Now, generally any block or solid material has got 12 degrees of freedom. What are those degrees of freedom? It can move along x axis, say in this direction or that direction, plus or minus, along y axis, this direction or that direction. It can move up and down. So, 6. It can rotate around x axis clockwise or anti-clockwise. It can rotate about y axis clockwise or anti-clockwise. It can rotate about z axis clockwise or anti-clockwise. So, there are 12 degrees of freedom. So, all these 12 degrees of freedom have to be arrested by locating, supporting, and clamping, that is before machining. How? This is the blank. Okay. So, this has to be supported here on 3 pins. Say this is the top view. On the top view, you see the 3 pins here. From this side, supporting and locating with respect to this distance. Then from this side, the locating, and this is the side view. Okay. Now, so by these pins, we arrest 9 degrees of freedom. Now, if we apply a force from top, clamping force, one force from this side x direction, and one force from say this side, okay, this side, then all the degrees of freedom will be totally arrested. So, this is the basic principle to be followed first while locating, supporting, and clamping. Now, locating blank in jig or fixture, design principles for the rules for locating. One or more pre-machined surfaces or holes are to be used for reference. That means, suppose here is a block. Okay. Now, first of all, it is say produced by casting or forging or something, all the surfaces are irregular. So, first you machine one surface and bring it to the flat surface. You can machine another surface for this, using these 2 surfaces are locating. You can make some hole also initially, which will be used for locating purpose. So, it is said that one or more pre-machined surfaces or holes are to be used for reference. This is a must. Okay. Now, next is which surfaces should be selected for pre-machining and location. The referencing surfaces or holes should be important features based on which other dimensions are laid down. That means, if suppose this is the blank, this is the blank, okay, and here is a hole with respect to which other holes are dimensioned. Then first of all, this hole is now located with respect to this surface. So, this surface has to be machined, the bottom surface has to be machined, then you machine this one. So, while machining this hole, use this surface and this surfaces as a locating surface, and then for making all these holes, use this hole and any surface as a locating, because these two are important with respect to which dimensions of other pieces are laid down. Now, locating should be easy, quick and accurate. It should be cumbersome, it should not be difficult, it should not take time. Locating pins should be strong, rigid and hard. Why? The locating pins will be subject to stress, so it should be strong. It should be subject to deformation, so it should be rigid, and it should undergo wear and tear, so it should be hard, that is wear resistive. Locating pins should be wide apart. They should not be very close, then the purpose will not be served. V blocks and cones are preferably used for cylindrical jobs. Now, here you see there is a job, is a pipe, like this is a pipe, okay, which has to be located, support a mounted in a lathe for some work on a milling machine. Suppose one hole has to be made here, okay. So, this has to be located by two cones and apply pressure. So, it will locate a supported clamp simultaneously. For cylindrical jobs, here is a V block. So, this is a rod, you place it, the center of the rod will be automatically aligned with the axis of the V block, and this will be kept. V block is already kept in such a way on the table that its axis and the axis of the drill are already aligned. Now, if you put rods of any diameter within limit, the axis will be always within this axis of the drill as well as the block. So, it goes self centering or self locating. So, you have to take this advantage. Now, continuation, site location for jobs of irregular surfaces. Now, here is a job, you see that is a plumber block bracket. This is a flat base, it has got a flat base, and there is a projection where there is a hole through which shaft passes, all right. It may be like this, it may be like this, a 3D if we draw, it will be like this, okay. Now, first of all, this hole is very important. This is with respect to this surface, but this surface is now irregular. So, this surface has to be machined first. Now, when you machine this surface, it should be very done carefully. If you machine an inclined way, then it will be erratic. So, first this surface has to be machined carefully with a minimum effort, minimum material removal and so on. So, this has to be placed on two pins by inverting it, and it has to be clamped from side, and this surface has to be machined by milling or some similar tools. Now, this is site location, okay, and then after machining this surface will be used as a locating surface for machining the subsequent features like holes and so on. Then we have to make a hole here, one hole here and so on. Next is pivoted arm may be used for locating and supporting large jobs. You know this, for large job, for any job in a flat surface, for locating 3-point contact has to be there. Always the minimum number of pieces required is 3 points. If you use more than 3 points, the fourth point may be or may not be in contact. But if the job is very large, one of the pin location or contact should be replaced by a double point location, that is pivoted type, which will be pivoted here. So, these 2 points will be functioning equally. Adjustable pin or screw are to be used to accommodate part size variation, and this has already been mentioned. Now, general methods of locating. Locating workpieces for machining in lathes, which are very common work, by fitting into self-centering chuck, by fitting into collets, mounting in between say centers. Here is the job, you put one center here, headstock center, tailstock center, it will be automatically aligned. Of course, it has to be held in a position by a dog or catcher driving plate. Mounting on mandrel held on spindle, this will be shown later on, and fitting in a fixture mounted on a face plate. Now, here this is a face plate which will be fitted into a lathe. Now, suppose this is a job, odd shape, maybe odd shape and all these things are there, one hole has to be made, by a drill, now in a lathe. So, what has to be done? A fixture has to be mounted on the faceplate and this has to be clamped on this one and then you use it. So, there is fitting in a fixture mounted on a faceplate. This is the faceplate and this is the fixture and this is the job. So, this is how it is done. Locating for machining in other than lathes. Other than lathes used very frequently, but most of the work are done in machines producing flat surfaces like say milling, planing, then broaching, boring, drilling, grinding and so on. In those machines the job do not rotate. Lathe is the only machine and cylindrical grinder where the job rotates. In other machines job remains stationary. In those machine tools where the job remains stationary, what will be the locating system? Locating by surfaces. Here you can see this is the job which has to be located with respect to that certain height for some machining work suppose. So, this is the locating arrangement along vertical jig. Now, this suppose one hole has to be made along this axis. So, this has to be located first on a flat surface and then by a pin. So, this end will be arrested by a pin, this end will be arrested by a pin and these pins or plugs may be of various type depending upon the requirement. You can choose these pins which are available in the market and preferably you choose standards as far as possible. Now, locating by holes. Now, here is a connecting rod. Now, suppose it has got two holes already. It has got two holes already, one hole here and one hole here. Now, and let us assume that one slot has to be cut here or one hole has to be made here. So, first this has to be held strongly into the fixture or jig. So, this is the plate, base plate, and there are two holes and two pins are fitted and on that this bracket has to be placed so that the two plugs or pins are in position, so that it will go neither this direction nor in this direction and this has to be clamped by a clamping force. Now, you do the machining work. But one thing to be noted that this distance of the holes is assumed to be fixed, but it will not be fixed. There is always a machining allowance. Therefore, a small gap here between the pin and here has to be maintained to allow this machining, this variation or tolerance, but it cannot go in this direction or that direction. This kind of pin, suppose instead make it here and here, then you reduce here, means a gap. These are called diamond pins. So, this kind of diamond pins have to be used. Now, suppose you want to make a hole here, then you cannot use this place for locating. So, this will be done by this hole is there by a locating pin and now this movement or rotation has to be arrested by a pin, external pin or outer pin, and a clamping force has to be applied here, so that all degrees of freedom of this bracket is arrested. Now, you do the drilling by jig. Now, this same kind of bracket, if you want to make a hole here, then you can hold by a plug through a hole already existing or pre-machined and this surface will be arrested by a V block. So, this is totally arrested and now you can do this hole. Locating on mandrel or plug. Now, here this is the job and this is the mandrel and then this will be held in the lathe or in a machine or a bracket or fixture and mount the job and then by a nut you hold in position. Now, you make a hole here by drilling and then you can index it, and make radial hole say 4, 6 etc. Here is also the same thing. This is the workpiece which is mounted on the plug. This is the plug, all right, and this matches here and this is a jig body. Now, you put one washer here and then one nut. By a nut you just tighten it and now you can do the drilling and other operations. Supporting principles and methods. Design principles or rules for supporting. The job has to be supported strongly and rigidly on certain surfaces. First rule is that any job or surface has to be placed on 3 pin or 3 contact points. So, minimum 3-point contact required to support has to be maintained. Supporting pins or these supporting pins or plugs should be strong, rigid and hard, because they have to take a lot of force and stress, deformation, etc. Now, unsupported span should not be much wide. Now, suppose there is a block or bracket to be machined or a part of a machine tool. So, this is the bearing surface and this is the bearing surface. Now, when you clamp it here on a machining force, this is the tendency that this may sag and the accuracy will be lost. So, this kind of wide gap should be avoided. Design principles, now continuation. Supporting should keep job stable. Now, this is the workpiece. There are two supports, and if you load it here, force it here, then this will topple. So, this is not correct, unstable and not correct. Now, the support has to be away from the force on both sides. So, this is correct and stable. Now, recess to be provided within wide contact area. Now, this says actually, suppose this is the surface and this is a large job which is supposed to be resting on this surface, but to assure contact here and here, one recess or relief has to be made here. So, that contact here and here be assured and this will be more stable. It is also true for holding jobs, long jobs on V blocks. There should be one recess. So, the contact will be here and here. Now, the design principles continuation. Cylindrical jobs are to be supported as usual on V blocks. Now, additional pins are to be used to compensate part size variation. If the part size varies widely, then additional pins will be required. To support large and heavy jobs, more than 3 supporting pins will be required. To prevent deformation of job by heavy forces, more supporting pins will be required. But remember, the additional pins beyond 3 should be adjustable, because the contact will be, suppose this is the block, there are 3 pins, these 3 pins are sufficient. Now, if you put another pin, the contact may not be there. If you force it, then the contact will be lost. So, the additional contact should be such a way that this is a pin spring loaded and this will be allowed to contact, then you hold it in position tightly by a nut. So, this should be flexible and like that, it will be explained. And mandrel may be used to support locate blanks, which has already been explained. Now, common methods of supporting on vices, which is done in say drilling machine, milling machine as usual without fixture. Of course, vice can be considered as a fixture, low level fixture. Supporting at flat surfaces. Now, here the supporting the job at flat surface 1 and flat surface there. Supporting by flat surfaces, supporting by fixed pins or plugs. Now, here the flat surface which will be supported by pins, 3 pins and there is 1 pin from 2 more pins from the back side and so on. But these additional pins, as I told already, should be flexible. That means that if this be the surface, of the workpiece, this pin, this plug should be gradually meet the surface. Suppose here, this is the workpiece which is very heavy and this is the 4th one or additional pin. So, on this compression spring has to be used, this pin has to be pressed down, and after unscrewing the nut, then you allow it to come into contact under the action of the spring. When it comes into contact, then you tighten it. So, this is how the additional pins have to be utilized. This is one. Here, this screw has to be rotated gradually to bring this end in contact with the workpiece. After that, this locking nut has to be used. This is another. First of all, this has to be unscrewed, this pin has to be withdrawn. So, under the action of the spring, this will automatically go up and contact here. Then you tighten this one, that will remain fixed in position. Here is another, this is the work surface, you just unscrew it and then you pull it here by operating this knob. So, this will move in this direction and this will come, this will go up and in contact and then you tighten it here. So, this is how these are utilized. Design for clamping. Design principles or rules for clamping, holding tightly. Clamping must be strong, rigid and stable. Must be strong so that it can withstand the stresses or forces. It should be rigid, should not undergo or create deformation, and it should be stable, so that it can hold the job strongly, rigidly, and there should be no additional movement within the parts of the clamping system. Should be easy, quick and adequate, enough force can be applied to counteract the cutting forces. Should not hinder, the clamping system should not hinder loading and unloading of the work. It should be so designed that loading of the job and unloading of the job from and to the fixture should be easy, uninterrupted. Clamping force should act against a rigid part and not damage the job. Suppose there is a job like this, there are rigid portion and a thin portion. If you clamp it here, this will undergo bending. So, clamping has to be done on rigid surfaces. Next is minimum and standard parts are to be used for clamping. This is already explained. Wearing parts, the parts which undergo wear and tear because of sliding and pressing have to be hard, wear resistive and replaceable time to time. Whenever they wear out sufficiently, they should be replaced. Clamping should be foolproof. Yes, the clamping system should be such that the operator cannot do mistake, even if he is absent minded or slightly indifferent, so he cannot do the mistake. Reliability, the work should be done reliably, repeatedly, safely, and the overall cost should not exceed limit. Now, methods of clamping in fixtures. Now, there are two ways of clamping: ordinary clamping, quick clamping. Ordinary clamping are obviously slow. Now, what are the ordinary methods? Screw operated strap clamping, very simple. Here you can see that this is the workpiece, it is a part of the workpiece. This is the workpiece and the part of the workpiece where it has to be clamped, a force has to be applied, that will be given by a lever, okay, and the lever is resting on a plug or a support, and then by operating this knob, this will move down. So, there will be reaction here and this will be force acting here, and when you unscrew it, the spring will push it up. So, it will go up like this and the job can be easily removed. Now, here one thing is to be noted here, very important. Because of the loading and tightening and loosening, this strap may undergo bending, okay, like this. So, there should be one spherical washer. So, the spherical washer is like this, spherical washer which works in another washer which has also got one cavity like this. So, this can tilt with this. So, this will be taken care of. Now, this is the other side, other part. So, this is the screw, clamping screw. If you rotate it clockwise, this strap will be raised and this will move down and apply the clamping force on this workpiece, the part of the workpiece on the base plate. Now, clamping from side or through machining. Now, suppose this surface of the workpiece have to be machined through machine, like milling or planing or broaching. There should not be any obstruction like clamping anything. So, clamping has to be done from side. One force has to be applied here and one force from here. So, one force will be there and one force from here. So, this is how this will be clamped. So, there are various methods like this. So, that now if you tighten this screw, this strap will go this side and exert pressure here. If you screw here, this will tend to go up and exert pressure here by rotating about this inch. If you tighten this one, so this will bite here, hold and bite and hold here against this spring. Okay. This is very simple and used. Clamping using swing plate. Yes. Now, here this is the workpiece which is resting and the supporting and locating and now clamping has to be done. This strap, this plate or strap is swing type. So, this is like this, it has got slot like this. Now, this will be moved upward, then the job will be placed inside. After placing and locating, this strap will be moved down, and from here this is open here, and then this is swinging type. So, this locking bolt now will remain in this position, and by spring it will be held. Now, when this will be pushed down, this will be contact clamping point, then you bring this one in position and tighten the screw. So, this will remain horizontal and this end will push the job for clamping purpose. And this is this is swinging vertically up and down, but this is another system where this plate will swing horizontally. This is the top view. It is hinged over here. This is a pin fixed on this frame, and the job is mounted on this locating and supporting pins, and then this will be bring in position, and this will be arrested here, and now you operate the screw, this will clamp it. Other common clamping methods are vices, magnetic chucks and collets as usual. Now, quick clamping methods, these are really followed. Quick acting nut, very interesting. How does it work? See, suppose this is a jig frame, all right, and this is the workpiece, is a ring type. Is a ring type workpiece where suppose some radial holes have to be made by drilling like that. So, there is a plug, this is a plug which is fitted into this one semi permanently, and then this blank is fitted here on this bearing surface. Then this nut has to be used. This nut is peculiar. It has got threads, but at up to certain layer the thread it had thread like this continuous, but this one and this one is machined out. A hole has been machined at an inclined angle say 10 degree, and threads from here and here have been removed. So, now this how this will act. This is the nut. This has to be unscrewed. Now, this how it is fitted, during first you fit the job, then this nut from outside has to be fitted in. You hold it in a tilted fashion, so that these bearing surfaces where the diameter is larger than the diameter of the plug. So, this we enter. So, this is the movement. So, you move it inside, then you straighten the nut. So, you straighten the nut by tilting. So, this will come into position. Now, so there will be a small gap here. Now, you rotate it clockwise by half rotation, maybe maximum one rotation. This will come forward and apply force. Unscrewing will be just reverse. You unscrew say half turn or one turn in this direction, then you tilt it to remove this contact of the thread and bring contact over the flat surface, the clean surface, and then you push out easily. So, this is how this act moves with a half rotation only. Now, the clamping using cams, this can be easily seen that this is the workpiece. Okay, here the part of the workpiece which has to be clamped on this support, rigid support. Now, there is a strap which is hinged, which has got hole at the center, and through which a pin passes, and that is fixed on the base plate. Now, this cam you see, this eccentric cam, this hole is not at the center of this disc. Okay. Now, if you move it in this direction, so this one will get in, and there will be a force, this will move up this pin, because this larger radius tends to come in. So, this will tend to go up and exert pressure on this side on the workpiece. Against this is a hinge, and this is another. Now, here you see the radial distance gradually increasing. Now, if you move it in this direction, so this will exert pressure here. It is resting on this heel, and when you press it here, and this is reaction. So, the action will be here on the job, and this will clamp it. Now, here you can see the clamping. Now, sometime what happens, suppose this is the workpiece and this is the base, and now here the clamping force has to be applied through the interior. So, here this system and this system will not be applicable because it is not accessible. It has got certain small gap only. So, in that case, this kind of system has to be applied. What is it? This is the cam. You see, this is hinged over here, and this is a cam, and through which a screw hole is there, threaded hole, and there is another piece which is hinged over here, Now, if you rotate the screw, so this will first move in this direction, and this cam will try to move in this direction. But since it is a cam eccentric, this will be locked, friction locking. will be there. Under that condition you screw it and the force will be exerted here. When you unscrew it opposite direction, so this will be withdrawn and this will also move in this direction, the contact will be over and this force will be withdrawn and you can remove the workpiece. Now, the multiple clamping of cylindrical jobs. Now, suppose a number of rods have to be held or pipe have to be held simultaneously. Suppose there are these are V blocks, okay, V grooves, and you put these blanks here on the V grooves. They may be of same diameter, may not be. There will be slight variation in the diameter. Okay. Now, this will be held by one hinge like this. So, this is a strap. When this will be pressed, so this is the hinge strap. So, this will apply force equally. Similarly, you apply a strap here, apply a V groove type, and now there is a strap inclined, you apply force here. So, both this one will be now, these two will be connected by another strap inclined, so L type. Apply force here, so force will be exerted here, that will be transmitted here, all these 4 rods will be clamped. Similarly, this 4 will be also clamped like this. Now, if you join these two again, so by applying one force at this point, you can apply equal force on all these 8 rods, okay, and this is what it looks like. So, this will be swung up and moved down after mounting and tighten the screw. So, force will be exerted through this pin to all the pins and all the jobs. Quick acting screw. Now, suppose this is the workpiece, okay, this is the workpiece and which has to be clamped against this surface. Here is the screw, very peculiar screw. Now, this has got an axial slot and there is a pin part of this one on a bush. Now, if you pull it at this stage, this will simply come out. Now, when you clamp it, want to clamp it, hold it tightly, you push it first to the maximum extent, bring it in contact, this pin will be here. Now, you rotate clockwise. So, this pin will be resting and this slot will get into that. Since this slot is inclined, this will be gradually moving inside just as a screw in a nut and that will apply force here. During unclamping, you rotate it anti-clockwise and then you bring the slot under this pin and pull it out. So, this is very quick clamping, but it is exerted for used for light duty work, not for heavy force, because it cannot apply heavy force. Now, the drill jig bushing. Finally, I told you that the slender rods like tools which rotate with a run out, as a result accuracy get lost and it may bend, undergo buckling and may break because of the force. Now, for these things the bushes have to be used. What are the purposes of using bush? Let me repeat: to reduce or eliminate run out, to locate the tool in position with respect to the job, to prevent buckling and breaking of the tools, because it is a slender tool, under the thrust force it can break because of bending, to attain and maintain accuracy, safety and economy. Safety means to prevent breakage and damage and loss. Desired characteristics of these bushes: the material should be hard or it should be hardened at the mating surfaces, RC should be above 60. Finishing inside should be by grinding and lapping, outside by grinding, because it plays very important role on finishing accuracy. Bush's length: the bush's length, if you apply, suppose this is the bracket and this is the bush, okay, this is the bush and this is the hole. This bush's length, this length should be double the or greater than double the diameter, and diameter of the hole should be equal to or greater than slightly diameter of the hole to be made. Bush's length greater than 2 diameter and diameter of the bush should be D plus, where D is the drill diameter, and it should be seen that it should be quick acting, quick fitting, removal and replacement, do not slip unwantedly. That is, when the drill is taken out, this bush should not also go out simultaneously with the drill, it should remain in position. That is what should be assured. Now, types of bushes according to fitting: press fit. it can be press fit, slip type with liner and screw type with or without liner. So, it can be fitted by press fit, or it can be one liner can be fitted into that, another line, another strip, and screw type. Say press fit type is simply a bush press fit inside the bracket, another slip type a liner bush, and then within that another bush. Screw type that will be fitted by screwing either directly or within another slip according to head, either no head or with head or with flange head, which are clamped by screws. Now, this shows the frequently replaceable. If the bush needs to be replaced time to time, then this arrangement should be there. There should be a pin. Now, when this, and it has got a slot or step like this, when you unscrew this one, so this has got a step a slot like this, and then if you want to withdraw this, then first of all this pin has to be withdrawn, then you withdraw it, again you place it, then again you fit to screw it. So, this will be arrested here. So, the rotation will be prevented and lifting will be also prevented by the screw. But if it is to be wanted frequently, then it should have a gap and then a step like this. So, you can fit directly without disturbing the screw, place this one directly like this, and you simply rotate. So, this end will come under this pin here and this will be arrested. And this is for special type of bushes. If you want, so two holes very close, then this kind of single bush with two holes, or a bush with an eccentric hole. After making one hole, this has to be tilted by 180 degree. So, when this will be tilted, rotated by 180 degree, then just to rotate by 180 degree, this hole will be coming here, and then again use it, make another hole side by side. This can be done by mounting two holes side by side. This is also possible. So, friend, now you have seen that jigs and fixtures are so useful in batch production. This helps in basically locating, supporting, clamping, and the tool guidance very quickly, easily, and effectively, and every time the repeatability is always maintained. The same kind of work will be done repeatedly. So, the accuracy will be there and it will be maintained, and the worker need not exert much force or effort, and he need not be very skillful also. As a result, the total cost, quality and cost comes down. That is the advantage of using jigs and fixtures. But again I repeat, this should be used only in case of batch production, not for mass production. Thank you.